In this video, we're going to learn about stoichiometry, which is what is used to compare the amounts of substances involved in chemical reactions. As a recap, chemical reactions are kind of like recipes. So if you wanted to make a sandwich, you could say that 2 bread plus 3 meat plus 2 cheese gives you 1 sandwich. And you could say slices in each case. In the case of the synthesis of water, we could say that 2 molecules of hydrogen plus 1 molecule of oxygen gives you 2 molecules of water. And all of these are scalable. So for example, with sandwiches, we could say 2 dozen slices of bread plus 3 dozen slices of meat plus 2 dozen slices of cheese gives you 1 dozen sandwiches. Well, in the case of the synthesis of water, we could say that 2 moles of hydrogen plus 1 mole of oxygen give you 2 moles of water. So let's say that we have this chemical equation and we're told that we have 3 moles of oxygen reacting with excess hydrogen, and we're asked for how many moles of water can be formed when this happens. What I'll do is I'll put the 3 moles of O2 right here directly below the O2. And for the hydrogen, I'll just say that there's excess. This just means that there's more than enough hydrogen to react with the oxygen that's available. And we're trying to find the amount of water, the moles of water. So below the H2O, I'm going to put a box and I'm going to say moles here in the box. That's what I'm trying to find. So I just need to figure out how I get from moles of O2 to moles of H2O. And we'll set up dimensional analysis. We'll say I've got 3 moles of O2. I'm going to multiply this by a conversion factor, and note I've got 1 arrow here, so we're going to do this in 1 step. We're trying to get to moles of H2O, and all we need now is a conversion factor that will make this work. Well, I know I need moles of O2 in the denominator so that it cancels with what there is in the numerator, and I know that I want moles of H2O in the numerator, because that's what I'm trying to find. And if I look at the chemical equation, I know that for every 2 moles of water, that's this 2 right here, I need 1 mole, there's an implicit 1 here, of oxygen. So simplifying, I have 3 times 2 is 6, divided by 1 is still 6, and we have 6 moles of water would be our answer. Now, that was a very simple mole-mole calculation. What if we have mass? What if we say that we get 18.02 grams of water, not moles, but grams of water. And we're asked about the mass of oxygen that was used. Mass, of course, is measured in grams. So this is what I'm trying to find. I have no way of getting from one to the other directly, but I can go to moles. And that's something that we've seen in this course previously. When in doubt, convert to moles. So if I start off with 18.02 grams of water, I can convert that to moles of water. And from moles of water, I can convert to moles of O2. And from moles of O2, I can convert to grams of O2. Anytime you have grams and moles, you need molar mass, and I can do this over on the side. For oxygen, we have 1 times 16.00 grams per mole. For hydrogen, H2O has 2 of them, so we'll say that there's 2 times its molar mass of about 1.01 grams per mole. This gives us 2.02. This gives us still 16.00. And what we end up with is 18.02 grams per mole, grams of H2O per mole. Good. So that's the conversion factor that's going to get me from grams to moles of water. I know that according to my chemical equation, that for every 1 mole of oxygen used up, I get 2 moles of H2O, and that's going to get me from moles of H2O to moles of oxygen. And then finally, to get from moles of oxygen to grams of oxygen, I say that we have 2 times 16.00 gives us 32.00 grams per mole of oxygen, right, of O2. All right, great. So now that I've got this mapped out, I can do my dimensional analysis. So I start with my initial measurement, my 18.02 grams of H2O. I'm going to multiply this by 1 mole over 18.02 grams. And it's important to write it's 1 mole of H2O. The reason why I'm putting this in here is that my next conversion factor also involves moles, and actually moles of two things. But I want to make sure I put moles of O2 in the numerator and moles of H2O in the denominator. So my grams of H2O are canceling out. My moles of H2O are canceling out. I've gone 1 step, 2 steps, and I need 1 more step, which is to multiply by 32.00 grams of O2 for every 1 mole of O2. And the moles cancel out, and I'm left with grams of O2, which is exactly what I want in my answer. And if I do out the math here, I get 16.00 grams of O2 with the correct number of sig figs. So that's how you do a mass problem. Anyway, that's all for stoichiometry intro. Hope this video has been very helpful, and please feel free to leave any questions or comments in the comment section below. Thanks for watching.